And digital drilling, I was in for 11 years of my 24 years career on developing uh, digital technology for drilling, especially more relatively well construction from planning and execution. So as requested, what I've put together is just some slide. Probably some is not so detailed that you can see because I cannot really talk more in details about specific products or anything, especially many of them also what is SLB. But I will tell you about it, and hopefully you can understand what I'm talking about without really need to see details, right? So and you can stop me at any time you have a question. I don't want to keep talking by myself, for next 1.5, I don't know, 1 hours or 1.5 hours. Let's see how it goes. I'm more than happy to discuss thing, right? Uh, so let's start with here, right? People have been talking about digital transformation, and then what is the motivation? The motivation, of course, we trying to make, we want to use this technology, whatever the development in digital technology, trying to see if we can bring some savings or some value into oil and gas industry, right? And this is what some consulting companies seeing what is potential estimates, in terms of the cost or the spending, right? How much if we develop things more digitally, something available digital technology, the value can be big, right? It vary depending on which part of the life cycle of the oil and gas industry, but the saving is huge, right? Um, so the industry see that there will be potential and expected digital transformation or developing something with digital technology. It can be the next game changer for oil and gas industry. And in terms of comparing with other industry, we've been way behind of any other industry. You see, I don't know if how you've seen the the progress in many other sectors in your life, right? The tourism and the banking. Now many places I don't even see any bank again as a building. I don't see in customer service or tailor or retail. I mean, what do you call it? That the person that help you in the bank, now everything is online. I can transfer money. I can take money from ATM or whatever it is. I can swap my card. I can do whatever through mobile phone. Yeah, tourism. Before I need to go to travel agent. I need to tell them. Now I can do it myself. Buying ticket. I can choose my itinerary, my plan, and everything. I can learn from somebody else trip, and etc. Automobile. There is many thing in the car now. Always have this big screen that you can touching thing, and you can do cruise control, etc. All in gas. Many things still being done manually, right? But this is a big amount of money that being involved in oil and gas, and then so there's people thinking, why not develop something better with digital technology? So the drilling challenge, what we're talking about, well constructed drilling, the drivers and the pain point is remain the same. The drillers or we're drilling engineers, what we want is all this, right? Increase efficiency. We don't drill faster, reduce NPT costs, deliver on budget, etc., etc. But at this point, all the drilling teams still doing a lot of this, right? Sometimes we don't deliver performance consistently. In a good day, we deliver a good performance. The next well, we still have some NPT. We don't drill as fast as before. Lack of collaboration. When we put together a drilling program, there's a lot of people involved, right? A lot of from third party involved, service provider, vendor, etc. But we doing everything by ourselves. We running the simulation If drilling engineering running a simulation token ready is asking trajectories, asking drill string design and everything, cementing need to do a simulation is asking the same thing again. So if later on mud engineer decide, oh, I need to change the mud width, then you need to make sure you share it to everybody, because then everybody need to rerun the simulation again, right? So there is missing workflow integration between one step of design process to the next step, right? So it's disconnected. And then of course, when you start inputting everything manually, there's always chance of human errors. You repeated some mistakes. You don't know what been learned before, right? And then you repeat again the same mistake on the next well, etc., etc. So now what is available in terms of digital technology? All these things is available. Probably there's many more. I get to summarize it like many couple years ago, like 4-5 years ago. So probably now there's more like what is it? Quantum processing, right? That expected your computer can be as fast, 100 times faster than what you have capable now, and everything is getting smaller. So all this thing is available. Then the question is, what can be changed in terms of our planning and execution process and evaluation in well construction, utilizing some of this digital technology, right? The process in well construction is remain the same. We always plan, we deliver the program to the rig will operate or execute, and then during the execution, we record some of the data, right? There's so many sensor, there is so many report, etc. Based on that, we want to learn what happened if everything went well, everything not well, what it fix, and then when we're planning the next well, we want to learn from this. The process still the same, plan, execute, evaluate, what we normally told, right? So, but when we try to look at each of these steps, we want to see what things can be changed, especially with the help of digital technology. We want to be more collaborative. If I can input one time trajectory in one place, other people can be utilize the trajectory very easily. I don't need to copy and paste or input manually one by one. If mud engineer already defined a mud program, I should be able to just take it and use it for my other simulation, right? If everything is connected, can computer help us to automate it doing the design, right? Why human always, okay, this is the trajectory, this is BHA, this is the well geometry and everything. I click run simulate, you see the result. You see if things they don't like as we expected, you change something. Why don't we just tell the computer this is what I want, and then let the computer tell me what is the best design or the combination of design, right? And also then, instead of I'm spending time of reading all these records of the previous offset wells, especially if the offset well is being drilled in old days, in 80s or 70s, some of the exploration being drilled in old days, and then we have to use that as a reference. Do we need to spend time to read it, or I can ask the computer to read it for me and then just give me the summary, right? Or can I have a chat bot, right? I believe many of your generation probably now more familiar with the chat bot than me. It's like ChatGPT asking, right? You can then with the chatbot you have like a good assistant, right? Like Mr. Iron Man, the asking what is Java, and then asking, tell me, what is the best mud width to drill this Hordaland reservoir? I mean, section. Then you look at on the record and they say that, oh yeah, with 1.4 there's no wellbore stability. As soon as we use 1.3, there's wellbore stability. I wish I have a smart assistant that can tell me right away rather than I need to read, hundred of pages to trying to find that information, right? But of course, we cannot build one system for everybody. There's many companies there, but how different application, different software can just talk to each other and pulling data, transferring data between the software, right? Then after that, instead of we deliver a book of drilling program, right? Can we send it digitally? So then the system, the machine on the rig can read that program and then and probably the machine itself can execute the plan, right? But we want to deliver the top performance. We want to ensure that during execution we follow what the plan before, right? It's not like the guys in the execution, do whatever they want, while after many months or even sometimes years to making a plan, right? And then during drilling, we monitor it. We have a lot of sensor data downhole in the surface. We look at it. Do we need human to monitor it, or can we just tell the machine with some logic saying that if this exceed this value, call me, right? Or you need someone watching it 24/7 just to see when that thing cross the limit, and then he pick up a phone, right? Or if I want to optimize, I want to push more for a higher weight ROP. What ROP, what parameters I need to push, right? Do I need to push weight on bit? Because sometimes people thinking, oh, I can push weight on bit faster. I mean, to drill faster. Not necessary. As soon as you add the weight on bit, probably the vibrations start happening or the bit will damage earlier. So, but if you have a smart system that can tell you, looking at all the historical case, this is the recommended parameters for the best ROP. And then and the tendency, we collecting more and more data. We keep developing more sensor. We now can be capable to put some sensor in the bit, record, high definition of drilling dynamics. How do we store the data? How does data can be used? When people start talking about machine learning, AI, it require data to be able to use those smart system. But how do we share it? You don't want, and you end up collecting those data, but it just goes to the hard disk, goes to archive. No one look at it. The data is so big, and you just don't have a time to look at it, or even our human eye don't have capability to plot it, to see what's going on, right? And then how you learn from all those data. You should be able to learn better rather than just like we are reading the NOFL report and do it manually, start making our own note, etc. So any question to this point before I start? So the concept is remain the same. People see the benefit now. People start looking at what things can be done in every different aspect, right?
I have a question, Mr. Suryani.
Yeah.
It's quite hard to believe that an industry so big doesn't really have an automated workflow. Is that the case, or is the automated workflow so disconnected that it requires a lot of manual work to be conjoined?
Both of them, right? There is some part we managed to automate it slowly. There is some part it's just the data is too cumbersome. There's too much effort need to be done first before we start be able to implement those automation on top of that, right? The same thing, machine learning. If I give you all the offset well data, and probably many of them still in the hard copy paper, what you can do without it, with it, right? First, you need to digitize all those paper, and also sometimes even after you digitize, you're not even sure if the data is good or not, or still relevant, right? So sometimes people who want to implement this machine learning or decision system or automation, they just give up when they know that it can take weeks, months to have the data that good and to start building an application on top of it, right? So that is the story of industry now. It's not necessarily bad. This battle has been started since 2014, 2015. So it's almost 10 years. So we see some. So in this mention here is built on industry standard. So I'll talk about it little. And industry realize that we are as industry not good on how keeping the data between company. They all define under our standard. But what we want is we want to be able to have extensibility. What extensibility means the data can flow from one database to the other database. Doesn't matter is it Google or is it Microsoft or this AWS or this Halliburton's, Baker Hughes, Schlumberger, Exxon, because a field one time will operate by cell. Couple years the contract's finished. We will taking buffer by total. In the past, is hell of a job of many years when you different operators taking over because they need to do manually bring from whatever the old, let's say, cell system, convert it to total system. There's something happening in between, etc. Right. So I'll show you more about it. Right. So is that answer your question?
Yes, it does. Thank you.
Yeah. You will. I hope you will understand more the challenge and what is the what we've been achieved in the next couple of slides. So the first thing when we bring in this digital transformation is happening many other industries as well. We realize is a cloud computing. Why is this game changer? Because it's changing. First, it changed the way we collaborate. I hope everybody's here is familiar with the like Microsoft 365, right? You can update, you can work together in one document. Doesn't matter the person. There's 10 people working on it together. Doesn't matter that the people in the same room, same city, working in the same time, right? You can update that one document and you have a history record, who update what, and then that's what we want to collaborate. At the end of the day, what we deliver is the drilling program. It's still a document. We still work with the document, but now the document is digital. Or you can still print it as a copy, but at least now it's not like you sending email. Could you please update this? And then you next send. I already updated. Could you send the next person? Everybody can jump in together. You've been requesting, okay, please attach this picture there. Da, 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 da. That's changing the collaboration. That is possible because now we put things in the cloud, right? Not in one person computer. The second thing that make it different is how much is the computing power. If you rely, it doesn't matter how most expensive laptop, you still limited with one processor. You're limited with whatever the biggest hard disk you can put it here. It go to cloud computing, it's like this big, right? Doesn't matter who's provider. It can be Microsoft, it can be AWS of Amazon, it can be Google, wherever it is. But it's a scalable computing resource. If you need to do calculation, a small calculation, probably just small one dot of this one, they're doing calculation for you. If you're running a big seismic simulation or production simulation or dynamic simulation of drilling, then probably you need more computing power. The same thing with the storage. Before, oh, I'm sorry, I don't have space in my laptop. Now, depending how much data you want to store, it can be continue expand. So that is the game changing. So now based on that, when people start talking about, okay, we need to build a big data. Because now I'm no longer limited with the space. Now I'm not longer limited with the computing power to use that data. But the question is, how we feeding up this big database, right? So if you still have the old report, then you need to digitize it. And now there's a lot of technology doing this, right? You can scan it. It have this natural language processing, even handwriting. If the system smart enough, it knows how to digitize it, right? A lot of drilling report is already digital, right? People are already inputting in Excel or in Word or whatever for the last 20, 30 years. So that one, it just need to convert to the format that good for the database. And there's many data ingestion in the system, right? Depending how do you get that information and then how do you store it, and some smart sensor. So the idea is you have a database, right? But then the industry, before I talk about this, I think I'm talking about OSD or not. Okay, here. Let me jump to here. What is OSD? Then people realize, okay, it's good. Now I can collect everything to the database, right? But then realize, we cannot continue, each company define their own way of keeping the data. We need to have one standard. So when the data is being shared between operators, between service company, doesn't matter who's doing it, whoever, between the consulting company, they can right away using the data rather than I need to convert the data to my own format, etc., etc. So then this is happening in 2018, 2017, I think. Industry agreed. Okay, we need to sit down together. Let's agree on one data platform or data. What is it?
Framework.
Framework, or I don't know what is it. People basically, this data. What is how you handle the unit? How how do you need to store it, etc., etc. Right. So the idea is everybody will store it in the same way, right? So that one make it easy. So the modern data platform need to easy to find, right? If when you need the data, you know you can easy to access anytime, anywhere. You of course security is important. You need to ensure it's protected, and then you can integrate or different application work on top of it smoothly. So in the beginning was a group of operators with some of the big service companies sitting down together. They agreed, and then many operators joining, many, so even IBM, Microsoft, So I don't know. I haven't been updated what is the development so far, but at least this is the one good step of industry, because with this standard, then all this big provider, they can put on top of it is this automated machine learning. There's different tools from Microsoft, from cloud. They can develop it, right? Some of the visualization tool like Power BI, TIBCO, or you name it, can right away know, giving you a quick tool that you can just click rather than you need to write a code or you need to define manually. And then it giving any startup or any company to build an application on top of it, like smart application to, I don't know, to select a bit. Right? You will see some of the example before. So now you have a big data. Then the first thing that we want to be able to take a benefit is how I can learn better from the data, because every well design is always started. The first question that the drilling engineer will ask, I said, is there any offset well I can study before I make any decision on how many casing uh, need to be run, how to drill it, which bit, which tool that I have to use it, etc. Is always learn from offset well, because you don't want to repeat. If you know that the offset well, it's already happened. I got blowout, I got stuck. You don't want happening in the well that you plan. And what is the best practice from the offset well? And then you continue improve the performance from that, and you keep pushing until the technical limits of the equipment or the well, etc. And then of course then you want to be able, make it fast. The way it works, you just copy paste. I know this is the best recipe on this field, just use it. We've been crafted, over the years, drilling 20, 30 wells, and now we are no longer have any NPT. Then the next well, you just copy and paste, validate, keep going, right? So hopefully your planning time before, probably the first well, planning it for 2 years. Now you can even planning it in a week. That was the idea, right? So then it's all about developing the tools that help you to find the data in the offset well, right? And then if the offset well, I mean, if the system can also recommend you something, it's like asking ChatGPT. Right? I don't know. Probably you guys been using in ChatGPT. Right now, I'm start using ChatGPT as well. Now, even some ChatGPT can be implemented to a local database, right? Because the day ChatGPT is just processing the data behind it, right? And then you start asking those questions, right? You know, uh, whatever you want to ask, what is the weak formation? What was the last FIT being used? If then you start asking what if scenario. What happened if I increase by 0.2 ppg or all those things, right? And at the end, probably this is what interests you. Just tell me what make me, create me time versus depth. So it will learn instead of drilling engineer manually plotting this time versus depth of every single offset well is being drilled before. The application read it by himself, generate this plot in the background, and then at the end it just propose you the best estimate, right? So I've been talking about this one. So now after you learn, how do you plan the well, right? So this is always what happened in the traditional, or even many of us still doing it these days. How many software that do you need to use to plan a well, right? You expect planning the well is very straightforward like this, but it will be nice. I finish, I know where is I can put my rig. I know where is the target given from the DG. Okay, I plan trajectory. Good. Based on my trajectory, I can plan my pressure window. I can predict where is my formation tops, what is formation temperatures. Good. Then based on this, then I can plan my casing point, right? Wellbore geometry, what size of casing. Oh, good. Then I can start planning how to drill each of the section, what BHA, and that's it. Finish drilling program. That's what we want to be a reality to make our life easy. Apparently, that's not, right? You're doing da 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 da, and then when you design the run, and then they said, oh, of course, no, my BHA will not be able to deliver the trajectory. Now I need to revise the trajectory. If you revise the trajectory, the pressure wind calculation change, the formation tops change, formation temperature prediction change. Then you need to change the run again the casing design, right? You try it again. Can your did you find a tool that can deliver trajectory? If not, you keep doing the cycle. And in reality, this is what actually happened when you're trying to design a well. Every of single this workflow is connected to each other. You design one thing, it can affect many other calculations that you need to repeat. So then the question is how many times if you don't, you cannot take, someone design trajectory in one software A, and then you run the hydraulic calculation, and if I cannot easily taking this trajectory and then just click say update, then you basically you call the guy or you send email, please send me the latest trajectory. He gave it to you. He give it to you in text file or in Excel. You copy paste, you input it to software, click run again, you know. And if trajectory is being designed 20 times, you do that 20 times, right? And sometimes one person changing trajectory because of the casing, and later on is causing issue of the BHA, for example, right? And then you need to sit down together meeting and then trying to find compromise, etc., right? So with digital technology is saying that, okay, if this is the issue, how I can connect all these different workflows, that not necessarily have to be in everything located in the same software. As long as I have software A and software B, I can talk, and then transferring the data or everything, reading the data in the cloud in the same data source, then you remove the hurdle. Or let's say if the system is connected, as soon as somebody update, for example, trajectory, give notification, and the notification that say, okay, A changing this trajectory, this is the latest trajectory, and then you have option in your software. Do you want to rerun all your calculation? Just yes and no. If you click yes, it rerun everything and then tell you, for example, the impact of the trajectory design is increasing 200 psi pressure in this in 12 quarter. Then he'll see. I mean, but it's still below the pump pressure limit, and that's it. We say, okay, yeah, those change is not changing much in or giving any other issue. So you want the tool that being developed in this area, so drilling engineering tool or well planning tool, the expectation now is to guide you on those process, to map you who's doing what, what is the progress, is someone waiting to run hydraulic because the drilling fluid was not designed, right? Instead of you keep the drilling engineer or whoever the project lead trying to keep track that is in his head, right? A lot of people keep track in his note. The system telling you. So first time in the morning, you look at it and say, oh, okay, now this task need to be done. What is the due date? If it's past due date, you can just call the guy. Could you please update this so people can keep move forward and everything, right? So you need a tool that it called orchestrated planning. It's kind of manage the team collaboration. It track how things progressing from 0% to 100%, and then make sure whatever is being done is following the company standard. Of course, then the company want to make sure people are following the way that the company approve as per the standard, right? And then based on that, you can make your life of people in the team is easier rather than having this thing in their head, right? So that is the first step, right? It knows what things to be done and then it guide you and everything. Then the next question is, can some of these tasks can be done automatically by the computer, right? If the computer now have the big computing power, can now start proposing a design rather than you manually doing it yourself, keep trial and error. So to avoid that, to minimize this, so you try changing something, change number, keep run again. Can the system just tell me, what is the best size of tool to run in this whole size, etc., right? And then, or if cannot tell you automatically the best design, at least tell you, if I run this tool, is anything gonna fail? Is my total torque will fail, or my hydraulic, the total pressure will fail, etc., etc. So the step can be like this. So it knows what different design need to be done, right? I hope people here familiar a little bit on what things involve on making a drilling program. Yeah, you have to design the fluid, you have to check the casing integrity, you need to design trajectory, you need to select the rig with all the equipment and whatever the specification of the equipment, you need to calculate kick tolerance, etc., right? Then the idea is, if someone making changes on one of these objects, for example, changing a trajectory, in the background, it should just trigger, all those different engineering calculation. So we always engineer when design something is always a validation check. You calculate the hydraulic, see what is the ECD, what is the total pressure, how is the hole cleaning. When you try to run liner, what is the best speed? Is the speed is okay, or is gonna causing swap or surge? Can you pull it in case you stuck? In case you rotate, is the torque still can be handled by the makeup torque of the casing joint or the BHA or the pipe or even the top drive, etc., etc. So if you have a system, remember this is connected to the scalable computing power. As long as someone said, okay, this is updated trajectory, please rerun all different of engineering calculation and tell me if anything fail, and then tell me through this traffic light system, right? Green, yellow, red. Then I can start right away rather than, oh, okay, I need to remember, I need to manually calculate hydraulic again. Sometimes people forget and then suddenly send things on the rig and then they say, oh, why we cannot pump? Because it exceeds total pressure. And then just because he forgot, oh, I extend the trajectory by 300 meters, and then I didn't check again if the hydraulic still okay. But if this thing is always automatic calculate, it's become like a dashboard, right? Until you don't make all this thing green, you don't deliver the drilling program, right? Same thing, trajectory design. You guys might be familiar with the Google Map or any mapping application. When you go to somewhere now, I cannot drive without it, right? The first thing before you drive is you typing where you want to go, and then let the application choose you what is the best path, and then you just drive following that. Turn left, turn right, turn left, turn right, right? The same thing with trajectory design. Why I have to manually design the trajectory if I know where is my surface coordinates? I know where is my target coordinate. I can ask the application become like a Google Map, generate me the best path, right? So what you need to do is just giving a criteria. And of course, if you have a surface location and you have a target, you can end up with thousands of options. Where is how this path goes, right? So like this one, when we give this constraint, this is my surface coordinate, this is the target. I want to kick off below 800, don't kick off shallower than this, for example, right? I only want to see the option between 3 degree to 12 degree dogleg. Don't give me any dogleg, more than 12. And how you want to approach this landing point, etc., etc. You click apply constraint. It calculate me 426 different possible path, right? And then you choose you want curve or curve hold curve, or then how you want to choose one among these 426. You can play around with this one. I said that if my criteria is I want to drill with this the shortest total depth, and you just scroll it this one, it will tell you which option is giving you the shortest total depth. If I say that I don't want anything more than 5.7, then giving me option that. So now the workflow is changed. Before you manually design and then you look at it, and some other people look at it. The more you're showing it to more people, the more idea, and then the more you get confused. You tweak here, tweak in there. Now is you changing. You ask the computer run me every single possible path, and then you show it to everybody. Said okay, let's decide. You choose which one of the best among these 426, and you're playing around with this filter, and then this keep changing, and then they say okay, that is the best part. Then I'll pick that one. Same thing when you run an engineering calculation. Doesn't matter whatever calculation you run, casing design, kick tolerance, torque and drag, hydraulic tendency. Those results is combination of parameters, right? And normally you run it once, you see the value, you don't like it, you change something in the parameters, you run it again, and then you keep doing those one. Now we ask the computer to do it differently. Say that I want you please run the hydraulic calculation and hydraulic and torque and drag for all this section, right? Calculate every 100 feet I'm drilling, and I want the combination of, we call it sample rate 4. So I mean calculate me with 4 feet on bit, 4 RPM, 4 flow rate, and 4 fluid density, right? Or in this case 5555. You submit. Of course, it goes to the cloud using all this computing power of this the cloud server, giving back you the result. Now you have thousand, even millions dots that you need to display. Then of course, when you display it, you need to have interactive display. Excel will not be able to plot this output. You need to something like more powerful, like Power BI or Spotify or whatever it is. Then now you can see, you can choose. I want to see all the result with 122 RPM, right? And then the graphics scene. And so instead of you manually one by one and keep changing, now you ask them to calculate first, and then you evaluate. Based on this, it can tell, right? If this is the limit, the rig pressure limit, it will tell you that everything you see this green with 1000 GPM, you cannot use it. So I know if I using this the square one, it is a density 9. This penta is 10, and then later 10.5, and this is 11. If the mud weight is still 9, I can pump 1,000 gallons per minute until 7,000 feet. From that point, I need to reduce, right? Become blue, which is 925. And then I can drill with 925 until I hit around 8,200. And then now I reduce again to 900 or 850. So you see, by all these calculated, I can tell what is recommended parameters or recommended flow rate, the maximum flow rate I can pump before it hitting the rig pressure and what depth. Right? So that the computer can give you the answer as well of recommended parameters. Say, okay, you want to drill with always with maximum flow rate because of cleaning. This is what you can use, right? 1,000 until this depth, and then you reduce it to this flow rate until this depth, and then you etc. etc. Right. The same thing also if you're asking what if scenario. If apparently you need to drill with higher mud weight, you need to reduce the flow rate to be able to keep it etc. within the rig pressure limit. There is more limit you can add it here like ECD and etc. Right. So any question to this point? I believe you already seen how the workflow is changes.
Yes, sir. I have a couple of questions.
Yeah.
First, can we know what this software is called?
It's a drill plan. This is it's a SLB software, but you will see many other software like the one from Landmark, the one from I can't remember the company. It's kind of going to the same direction, right?
Right. So what I'm also seeing is that for every change, there is a branching path. So the computer will need to handle like 500, 600 branches. So in the end, it's like one of those charts that we use when we first learn about drilling to plot, a drill bit size, a casing size, and stuff. But now it's more dynamic. So because of this, is it true that we can use one or two wells to make a model for the entire field without using that many wells?
It could. I mean, I don't know the capability of modeling, right? We will talk about modeling capability if we can predict ahead, right? It's all about, how much is dealing with the assumption, right? If there is unknown that not represented by these two wells, and then it exists in third well, then your prediction is no longer good. Yeah. So pretty much the same thing in anything with the machine learning, right? How good is the machine being learned is depending how representative is the data that you have compared to what is the next well will be, or what is the next case will be, right? Same thing you're asking ChatGPT or whatever it is. The answer as good as what is the data before, and it is still, relevant to what you ask, right? Does that answer your question?
Right. So
Yeah.
it's a matter of uncertainty.
Yes. And that's the business in drilling, especially is managing this uncertainty. We hope we don't see any surprises because we've seen it before and we didn't forget about it. Right.
All right. Thank you for answering my
All
question.
right. Yeah. So now we're talking about modeling, right? Now we said it. No, I can do a lot of calculation. I can ask the computer to run me millions of calculation if I want. But the fundamental question is still remain the same. If all this calculation, how accurate is all this calculation, right? When we try to simulate hydraulics, how accurate is a hydraulic drilling hydraulic calculation today, right? So of course, many of our calculation is based on physics, right? Torque and drag is a static and dynamic. All these engineers have been doing this in many other industry, right? Hydraulic, you have a fluid dynamic, you have temperature effect and everything. Of course, those all the PhD, they run all these different mathematic model, and then later on those mathematic model is being inputted to the software modeling, right? But of course, the challenge of all this pure, we call it pure principle models, right? Either thermodynamic, fluid dynamic, statistical strength, whatever you call it, the mechanical engineering stuff, right? The challenge remains the same, might not capture all the phenomena. This is what I call it uncertainty or assumption, right? There's a lot of input involving on what actually happened in drilling. I know the size of bit that I use. Does that bit drilling or the hole that being drilled exactly the same as the size of bit I'm going putting inside the hole? Well, we can only know it if we run caliper to check it, to confirm that. I know the size of collar. It made from steel. This is the properties of the steel. How much is the strength and etc. etc. What is the stiffness? We can simulate that. If I rotate 300 RPM, is it gonna be inducing a vibration or not? Well, there's a lot of PhD been studying on that. But of course, at the end of the day, it may not still capture the phenomenon. What is the effect of the formation itself? What is the effect of the fluid that being used, right? What is the effect of time? I'm going the same depth on the first day, and then I go back again after 5 days. It's still the same condition. And then it requires expertise to understand that, why the value that after I calculate, then you need an expert guys to break it down and say, okay, this is the input. Then that's why the university, I believe you always being trained to do a manual calculation first. It's just to get an idea, to understand what is involved, what is input and what is output, and it can be time consuming to create and run, right? Then with a lot of data being used, the data give you a validation. Yes, this is, you simulate, you calculate the prediction is, let's say, 1000 psi. This is the actual, well, and it's also 1000, let's say 1100. So the uncertainty is 100 psi, right? And you do it again the second well, you got 1050. You get the third well 1200, and probably there is one outlier. As I said, in the next well I got 1500, and you're wondering what happened, what is the difference. But anyway, if you're building the data, now the question is, can I use this data? If you've been doing it at the same time, and then you always got, let's say, 1000, you don't need to run this calculation again and say that if you're using the same, I know it's gonna be 1000. That is simple term, right? But sometimes you don't know why is, and if the next time you get 1100, why was this different? So now the idea is trying to combine both of them. There is a benefit of this one, there's a benefit of that. We want to combine it. That's called hybrid model. The idea is we still rely on this pure principle because it's pretty good, right? You get it pretty close. Now you just have a variance, right? Let's say between those 1000, you vary between 900 to 1500. Now you use the data to trying to see this uncertainty and reduce it even more, right? So that it will increase the accuracy of the calculation, and that's what we've been using it now. Like how we project the BHA tendency. We drilling a well now. The well is even more 3D here and there. It's trying to see if what do you call it? It's getting more difficult. At the end of the day, it's always every well driller said it. Can you deliver those trajectory? And there's always a question for the directional drilling or whoever planning the BHA said, ooh, can my BHA deliver those trajectory? I mean, following the path as a plan. So now in physical model, Before it's just statistic, right? Force here, force there, or I can create this curve. Now you can run it to simulate the process of drilling a head, how the bit with the steering tool cutting the hole. All right, and then drill ahead and simulate. Yes, at this formation I can create this amount of dogleg, and then when you cross this formation, it's changing the capability and etc. Now with the machine learning, we reduce this uncertainty. So this, if this is the black one, is the prediction from the physical model. This one, the dotted one, is giving you the uncertainty, and the machine learning model tell you how big is the size of this uncertainty. So people who make decision can be certain, right? If you have a planned dogleg of let's say 9, you a bit worried because it could get 1 degree less, it can be get 1 degree more, right? But if you say that I will plan only with 8 degree, you little bit more comfortable. Say, oh yeah, worst day I only get 9. A good day I can reach until 10. So even with if I'm planning with 7 or 8, I will be fine, right? The other thing is digital twin, because we can simulate. Let's say this one is a pressure. I want to know the pressure when I pumping a fluid from a pump to down to the bit and go back again. How much is the pressure distribution? In the past, you need to put a sensor to know how much the pressure. Now, because we can simulate all this process and then getting more accurate and accurate, I don't need sensor. This is what we call it, the digital twin. You know the value of things without you putting a physical measurement. You make a representation of these properties digitally. And then you can simulate many things. And then based on that, then you can make a mini design. This is being done in other industry like an aircraft. When they're doing a design, right? Sometimes they don't make all this part right away and then they test it. Sometimes if they have a control of this and a model, they can create this physical asset in the computer and then see if everything will work before they actually making the actual part, right? So that's what we call digital twin. You can simulate things digitally before you actually need to trial and reward, because it's gonna be expensive. And this is the fundamental of if you want to predict ahead, right? To simulate things digitally, and then you use that to see what if I implement pretty much the same principle in Nextwell, what the expected value if everything, all the system will work, right? The same thing as people designing a turbine or or aircraft engine, right? Many other things that we learn from other industry. In drilling, we always dealing with the scheduling things, right? For example, this is a scheduling of the rig. If I have a fleet of 10 rig, where should go one? Oh, that's a big task for a person, right? Or even 2 person, or even a team. They're trying to save the cost, but as good as the assumption. Apparently in other industry like manufacturing line, right? Or even the scheduling of the truck, you know, they just put it in the computer. This is the 10 truck I have. This is all the job that need to be done. Please suggest me what is the arrangement of the task, which truck need to go where. So then the same thing we're being trying to implement into scheduling of our equipment, or rig, our supply boat, etc. And this AI schedule is actually developed by Google, I think, if I'm not mistaken. But of course, Microsoft have their own AI scheduler module that you can easily use. Same thing. Then you start throwing more question to the digital system. If I have a database, I know the record of performance and attach those record of performance to its a BHA performance record or BHA run report. Now I ask question back. If I'm gonna drill in this field, in this section, please give me a rank. Which one is the best? This one is like the best performing driving system. The best BHA type and everything. and it start looking at the data, analyze it for you, and giving you a ranking. So before, instead of you looking at hundreds of run report, probably now you just interested to see, to validate, let's say, the first top 10, right? Then you ignore the rest, right? Same also while you're drilling. I already show you kind of a bit of an idea on how, if you're asking, the system to run different scenario, uh, suggest me the best parameter. In that case, somebody just flow rate, it's just doing the same, this concept. The same thing I'll say, we've been recording. Every time we drill, we record everything, right? We're recording how much weight on bit apply, flow rate, pump, rather RPM use, and performance. Now you're asking the same question to the system, tell me, I'm drilling now in this formation, what is the best ROP, RPM, flow rate I need to use? Then, for example, the bit, you have a one bit design. You're asking how many bit I need to order. Is it gonna be survive? Then look at again the past record. It simulates the probability of survival. This concept is being used in many other industries as well. It used, for example, in the plane, right? To know when they need to stop the plane and do maintenance, right? They will simulate that, when what point it start failing, right? So if we can plan ahead to simulate this before we actually putting the actual equipment hold, then it give us a better idea to make a decision, right? There is many other thing. If you go digging in SP, people been trying to implement, trying to utilize on top of the data with different kind of a technique of artificial intelligence, machine learning, on different topics, right? On predict gas oil ratio, vitamin gas, what does this mean? It's saying that if I don't need to put sensor, someone measure it. If I have this properties, this one, just tell me what is the gas oil ratio right away. So I don't need human actually doing it. The same thing also, if you can predict formation types ahead, so then you don't need to put LWD in the hole, right? So then at the end of the day, as mentioned, for planning, what we deliver is smart drilling program. Now we want not only, well, in reality, drilling engineers spend a lot of time, like they become like a secretary, trying to collect different input from different people involved and putting it together as one nice document, right? Now the question is, can just everybody contribute? So how to make drilling program collaboratively? I mentioned at the beginning, that's why how people need to work. Well, Microsoft 365, like that's all the simple like that, been helping. But why not? If I just type in, I should not care about what font to use, what size. It should be adjusted for me automatically. If a table, overlap in the next page, I don't need should not I need to should not dealing it manually. The document should handle it nicely to make it still looks good, right? And if that the software helping you doing that, and I said you're freeing up a lot of time rather than you are a drilling engineer but you work like a secretary, right? And you don't. Many people do not want that. Now, any questions so far from doing a planning? That's kind of an idea how digital technology can help in the planning way. And some of them is already being developed as now. Some of them are still work in progress, right?
Yes,
Any question before I move to how we doing it, how we execute now?
Mr. Suryani, can you give a general idea of the time frame of building a digital twin? Is it like is it built throughout the life cycle of well planning? Like you just do one thing on in the real world and then you do it in the digital twin to simulate the effect like in real time, or is it built before and then used as a guidance to guide stuff before the planning comes into effect in the real world?
No, for both. You use it to help you to plan the next well, right? You simulate, if you already build digital twin and then you want to know if in the next well I'm gonna do this, what's happened. That's same thing. And you're right. Then the same thing will use in real time, basically. If what actually you see in reality is still following as what they predicted from the digital twin, or something changes, you will hear later on during execution. There's something we call it predictive analytic, right? So that's the concept is on top of this digital twin, like predicting, what is my expected pressure, 100 feet, 1,000 feet ahead, without actually I'm having a sensor in the hole telling me that, right?
So it's also
Yeah.
used as a diagnostic tool.
Yes. Both
Oh, okay.
diagnostic or even predictive analysis. So it can be, yeah, it can be both. Yeah. Any other question?
No, thank you.
All right. So let's move on. So have more time later on for discussion. So now after you have this plan, you want to execute. How we traditionally doing it? Yes, you define the drilling program. You break it down to work instruction day to day, right? But then the driller is still looking at what's going on the rig floor, looking on the monitor. How is monitoring it now? And how the drillers can identify there is something happening or some issue happening as early as possible, because the chances from the issue happening until you are in trouble, like say you get stuck or you get blowout or you got lost circulation, is depending on how fast you detect the issue. If you detect it as early as possible, you can avoid that, right? Then back again to how fast is identifying the risk and how fast you make decision to avoid that or to mitigate that. But then again, also how good is how consistent is the performance? Is it different performance between the day shift and night shift, or between winter and summer, or changing crew, right? So first is you want again you want the software, the digital system help you to guide you to doing your execution job, right? You want to execute as a plan. You want to manage the risk. I've been telling you, Bruce. You want to track your activities. Anything happen, you want to capture it so everybody can learn to the next well or the next shift on the next crew. You want to follow, make sure everybody follow as per company procedures, and then again how the data coming in, coming out as easy as possible, not dealing again with this manual things, right? So there's a lot of people involved between company man, supervisor, the drillers, or even in town, right? Remember the drilling program, but now on the rig, you cannot just give, okay, this is the drilling program. You give it a book and have everybody reading it, you know, and having the same understanding, right? What they need to see is now they need to see digitally, step by step, what they need to do. They only care, especially the drillers who in the steering wheel. They only need to do what happened. I need to do now until my shift end, right? And that's have to be very clearly you define it in the instruction coming from the drilling program. What is the flow rate? Is it still a 600 GPM, or I need to change it now because of the situation is changed? And all this is number, right? Then so how easy this thing, you know, dynamically review, validate if things need to be updated because situation change, right? It's important on how the team on the rig can execute as per plan, right? So before in the past, they just receive a piece of paper. If there's anything happening, they will write it down in the piece of paper. After the shift end, they need to write it down again in the other report book and everything. Now everything has to be done digitally in front of them, right? So the best time to recode things is when things is happening, but they have to be very easy, or sometimes need to be. I mean, not sometimes. It's it will be great if things can be done automatically, right? So the idea of that is basically if everything being happening digitally, then we can talk about the journey to automation, right? So in the past, you giving instruction, how human will operate it, and then later on, there is some assisted operation can be done in just click of the button, right? And then the local automation, like make up uh, to join a pipe together. You just press a button, the hydro wrecker grab the pipe and everything, connect it, make up a truck. Before was there is a crew have to physically bringing the tongue and everything. Now many rigs already have this automation. And then the single workflow autonomy is, I say now, for example, please drill this one stand down. The machine should knows what weight on bit to apply, what RPM, what flow rate, etc., etc. It goes down to the full autonomy. What is the difference? So if automation, it just run a command based on whatever you define, set of parameters. Do this step A, B, C. This is what the parameters you need to use, da 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 da. And then you can change if you already define if this value cross this value, do this, right? That's automation. Pretty much like you're driving with the cruise control in the car. You set what is the speed, and the car will try to keep on the speed, right? Adjusting myself. It telling the system a well-defined criteria. Autonomy is understanding the environment, how the system based on all the sensors being input to understand that okay, I'm drilling. It knows, oh, I'm drilling this formation. Oh, I'm drilling, and suddenly there is a kick. It knows, and then it will take decision based on that. That's autonomy. It fully operating system by itself, right? That making decision and then adjusting as how the environment changes. So the journey is already long way when the early making this different. Some mechanical system like this one, the pipe racking and everything, the screen, everything has been even from 1970. So it's not saying that okay, this is happening, but it's still a long way to achieve to this autonomy level. We still in the point of automation or single work autonomy. To go 4 5 is still the journey that this industry need to continue develop and go. So for example, like remote operation, now I can see what's going on the rig from my office, but that one is already started in 2004. That is a first remote control while we drilling a well in Cameron, Texas, but the operator, the operating the machine is in England, in Cambridge, right? UK. Yeah. So this is what the display on the rig that the drillers can see now. In terms of while doing steering or while drilling, it's all these parameters no longer this Martin Decker old gates and everything. Now it's digital dashboard, right? And then you can track, if the program defined use this weight on weight from 5 to 10, is while drilling is always keeping those 5 to 10. Or suddenly the driller forgot and released the brake and 1 point increase to 30, right? It giving you smart notification also, telling you, okay, there is a stick slip happening, a vibration happening. You need to adjust the parameters to mitigate that. And then after the smart system that they're telling, now we need to start bringing tools that helping drillers making decision, right? Seeing what is the parameters used. If I want to increase the ROP, what the parameters need to be used. I've been talking about, this how the system can, based on the engineering calculation or based on the learning from the past experience, then should be able to tell, okay, in this formation at this depth, based on the past experience, based on my simulation, use this number. Then the driller say that agreed, then it will adjust the top drive, the palm, automatically, right? And then later on, while you're drilling, then suddenly there is a stick slip or vibration. It give a warning saying, okay, this one, please follow this step, right? You agreed? Agreed, and it doing this. It reduce the weight on bit and increase the RPM within this next 15 seconds, right? So the goal is this one, right? The driller just need to watch and wait until something beeping or so. Now we managed to be able to, the driller said just go drill a stand. So it knows how to go on bottom, increase the palm, with on causing pressure surge, take on bottom, and then fully and making connection. When go to auto ROP, the driller said optimize the ROP. It knows what the parameters need to be adjusted and everything, the computer taking care of the machinery. If you need to send a command to downhole before the driller or directional driller MWD need to be adjusting the fluid manually, now just click a button, send this command to this tool, it will giving the sequence that require automatically, right? So even through the system, like a steering tool downhole, said, please, this is the trajectory plan. Please deliver this dog leg as per plan or catch up the plan if you deviate from plan, right? So that is in drilling front. What about all the data that all this machinery have a sensor on the rig? Of course, it also require maintenance. The idea is to schedule the maintenance, not in the critical time of drilling, right? So then you need to predict when is the best time before it actually completely fail, right? So the top drive, the draw works, all this big equipment. So if the system can read all those data, and then predict, okay, if we continue using the like this, in the next 3 days, the top drive will need repair. Then it will try to find in the next 3 days when is the time that I can do this maintenance without doing it in the middle of a critical of drilling time and then causing NPT, right? But sometimes this decision is hard decision, unless you have a system that help and analyze the data to and propose you those information, right? So how it's being done is just looking at those digital those digital twin, either by pressure or vibration level or whatever is this, depending what type of machine you're talking about, temperature and everything, and then they start seeing, giving you suggestion, the possibility of failure like this, right? Then people who need to find out the schedule time can put it in before it's actually completely failed and causing NPT. The other thing is video surveillance. We can easily put in any video camera in anywhere now, right? But the question is, do we need to put human behind it to watch it and then tell someone, you are in the dangerous zone or something will happen? Or I can get the video and then have a computer read the data and then only, send a notification alert, turn on the alarm when the dangerous is occur, right? So then now that can be done, and you just need to wait until it telling you there is something will happen, right? So this being used in truck loading, burner control, well site monitoring, all these different operation. And then all those information can also be sent to town, right? The person doesn't have to be on the rig watching all those things. But then now these days in the monitoring center, sometimes one expert can monitor 4 or 5 wells, because he doesn't need to look at the data coming in every single depth, right? He just need to rely on the smart monitoring. Whenever one of these is telling alarm, then he can see, review the information, make decision, right? And take action. And then after that, leave it the computer helping him to monitor the data and wait until the next alarm coming. So that is smart monitoring. But it will be good if during the monitoring also predict ahead, right? So it predict at which point that the torque will increase and which point the pressure will increase, and then moving toward the limit. So that is predictive analysis. Back again, relying on those simulation, how accuracy of simulation or those digital twin, etc. And then at the end is, after all this being monitored, at the end is what we always interested is give us a summary of the performance and which area we can improve. All right. If at the end, well, it can just summarize that, make a quick plot, then I know what things to think further for the next planning, or during drilling, what things need to be improved day by day. All right. So yeah, so all this is smart monitoring. There's many things can be monitored now, like a stack pipe. Tell me, beep me, or notify me if we are approaching a stack pipe risk. Also, dressing integrity. Tell me if there's potentially the vibration will damage the drill string, and drilling efficiency, and etc. Right. So I talk a little bit about the predictive analytics. It's just if I can start using all those models, simulation, hybrid modeling to predict ahead, that's even help us to mitigate the risk before it's actually happened, right? Yeah. So for example, this is predictive analysis using Bayesian network. Don't ask me the details. I'm not the AI expert, but they're using this concept. For me as a drilling engineer, was important. Just tell me the probability of stuck pipe, right? And notify me when that's going to happen. Then I can fix it before it happen, right? Yeah, looking at giving evaluation of the performance in a single well or multi well, so I can use that information to improve the performance of the well that currently I'm drilling or the next well that I'm currently planning. Right? There is more technology. For example, here people sometimes when we're drilling, we only see numbers, right? In the gates that we see in the surface. But it will be better if you can visualize what actually happening downhole, how the bit cutting the rock, all the load is involved, and that's what help with this reality, augmented reality, visual reality, right? For example, here during the wireline operation, the operator can see all this value. He doesn't have to be sitting in his truck seeing this. He can see using the Google Glass, seeing all this value while he's sitting there. If he need to access operating manuals, he can see and then tell the glasses, say, okay, I'm doing this, going in. Please tell me the procedures of this. It break it down. So yeah, then it help them to work in more efficiently. How to visualize the whole cleaning, or even as simple as just for a training, right? Simulate different case for training new people. So that's all I have. Kind of giving you, hopefully giving you a bit an overview how the digital technology being used or currently still being implemented or developed in doing well construction. All right, now I open for any question.
Mr. Suryati, I want to ask something relating to the nature of jobs in this niche.
Okay.
It's that it's already apparent how to strive towards a particular career path in the industry. Like if you're doing drilling work, then you should improve in that aspect and so on and so forth. But it seems like an alien type of sub-branch of drilling, this automated drilling and digital drilling. How does someone become a subject matter expert with this niche? Like what's the requirements?
So first, if I look at my career path, how I ended up here, my background, I'm mechanical engineering, and then I joined oil and gas industry with SLB, and then I've been trained. My background is a drilling engineer, right? So it's always the domain. This is always when we're talking about digital transformation. Before, industry was talking about, do we need a group of software engineers and then we teach them about drilling, or do we need a drilling engineer and we teach them about software? The answer is none of those two, because it will be difficult either way. So for my case, my background is always drilling engineers. That's my subject of expertise, right? But I've been have opportunity to work together with the software development team or software, right? What I need is I be able to talk with the same language with them. Not necessary. I mean, I'm not talking about English or Arabic or anything. No. I mean, it's when I'm talking about cloud computation. I understand what is called computation. When I explain to them, they also understand. So my point is, doesn't matter what is you are. The best part right now is be expert in your domain, whatever it is, right? If you're drilling domain, if you're reservoir domain, petroleum engineer, whatever, be expert on that. But you need to open yourself to be familiar with the digital technology, which I believe is not difficult thing for your generation, right? Learn about what is cloud computing. We call it a digital literacy, or it become a digital citizen. So you know what what is a cloud computing. You don't have to learn to be an expert on be able to code. And actually, some of the machine learning now these days is very easy to master. You don't no longer writing a code like any software engineer writing a code. Now you just drop or drag and drop a module. Some of the machine learning tool is already provided by this one, right? The Google, Microsoft. You just need to reuse it, right? So I think that is the best part, and I believe many of other domain, some of those paper that in the SPE, just collaboration work between these two world, right? But mainly drive by the domain expert itself. So some of this is just all this person is good in their domain, but they open themselves to work together with the software people, right? Or with the data scientists. Uh, Any other question?
No, sir. Thank you. Thank you for being here today
Yeah.
and then teaching us about this very very niche subject. Not a lot of people have
Mhm.
the experts to talk about it, such as you. And we thank you very much for being here.
It's my pleasure. Thank you for the opportunity.
All right. Thank you and goodbye, Mr. Suryadi.
All right. Thank you. Have a good day. Bye bye.